The first page a customer sees upon entering the CyberStorm Analyzer serves as a summary of the various findings. This page provides an overview of the different stages of analysis, including scanning results, analysis results, and AI-driven insights. The primary element displayed on the homepage is the organization's current risk score, along with a health trend indicating whether the risk score is increasing or decreasing over time. The risk score is calculated based on the number of vulnerabilities, the number of critical paths, and the number of critical assets present in the network infrastructure. Additionally, the page categorizes assets based on their security posture. These categories include assets with a very good security posture, moderate assets, exploitable assets, and highly exploitable assets. Each category is interactive. Clicking on a category redirects the user to the network topology page, where they can view the specific assets within that category. Furthermore, each individual point within these categories is also clickable, allowing users to navigate directly to the associated part of the system. The system also utilizes a large language model for two key purposes. The first is generating attack scenarios in plain English. These scenarios illustrate how an attacker could start from an asset with a public IP address and propagate through the network, identifying exploitable assets and vulnerabilities along the way. The second functionality of the large language model is generating a comprehensive defense strategy. This strategy outlines which vulnerabilities need to be addressed, the recommended remediation actions, and the specific IP addresses requiring attention. The vulnerabilities are prioritized in the correct order to help the organization understand which issues should be tackled first. To understand how these conclusions are derived, we can step back and examine the critical path analysis page. This page presents a complete graph that maps out all possible ways an attacker could navigate through the network infrastructure. Each node in this graph represents a vulnerability within the system. For example, if a vulnerability exists on an asset with an IP address ending in 68, the graph illustrates how an attacker might exploit that vulnerability to move to another asset with an IP address ending in 79. Rectangular shapes represent vulnerabilities associated with specific IP addresses that pose a risk to the organization. The lines connecting these blocks signify possible movements or propagation paths an attacker could take from one machine to another. This visualization allows organizations to identify all potential attack paths and targets. Additionally, diamond-shaped nodes within the graph represent critical attack targets where remote code execution could occur on a machine within the network. Some graphs may be highly detailed, which is why a criticality table is provided. This table explains each critical path, its level of severity, and the assets involved. The information from this table is then used as input for the large language model, which generates the defense strategy. The prioritization of vulnerabilities is taken into account during the generation process to ensure an effective remediation plan. This unified approach provides complete visibility into the network infrastructure, incorporating multiple factors. While the initial example focuses on vulnerabilities, other analyses can include Active Directory misconfigurations. These misconfigurations associated with different IP addresses are integrated into the graph to demonstrate how they can be exploited in an attack. Another important consideration in this analysis is the business importance of various assets. An enforcement learning engine evaluates multiple factors, including the asset's significance to business operations. This importance can either be manually defined by the customer or determined through integration with CYBRAL Guard. For example, an asset containing confidential or classified documents that could be shared externally should receive a high criticality score. This score is then reflected in the ranking and prioritization of critical paths. This approach addresses the limitations of traditional manual penetration testing. Unlike manual testing, which may overlook complex attack scenarios, CYBRAL's Storm Analyzer provides comprehensive visibility, identifying all possible attack paths and propagation methods within the organization. This enables organizations to proactively strengthen their security posture and mitigate risks effectively.